Okay, last time we were working on the wage data set. Okay, let's go back here. This is almost done, guys. Okay, so just a very quick review. We said that when we when we generate a multiple linear regression, okay, we would like to describe your dependent variable or response variable, making use of several predictor variables, or independent variables. There are some assumptions that are made as regards multiple linear regression. It makes use of the ordinary least squares method. So very quick review lang, guys, of the assumptions. Number one, linearity of the data. What do you mean by linearity of the data? There should be a linear relationship between your outcome variable y and your predictors x1 up to however many x sub n. It makes no point, guys, to run multiple linear regression if your variable is not linearly correlated to your, if your independent variables are not linearly correlated with your dependent variable or outcome variable. So for example, if we look at the relationship between x1 and y, and it seems that the relationship is more parabolic, okay, or quadratic, then x1 will become a poor predictor for y, okay, because the relationship is not linear. So that's the first assumption, linearity of the data. Number one, linearity. Number two is linearity of the parameters. We discussed this before. We said that the parameters, which are the slopes that we solve, that we compute, the beta 1, beta 2, beta 3, okay? We said that the slope should be linear. So hindi siya pwedeng naka-square root of beta 1 or cube root of beta 1 or log of beta 1, okay? It should be simply beta lang, beta null, beta 1, beta 2, okay? Hindi pa pwede siyang naka-power, hindi siya pa pwedeng may function siya because it will be very difficult to compute for that, guys, pag ganyan yung model natin. Kaya ang model natin should be dapat ano lang, no? Dapat linear lang yung mga parameters natin, yung mga beta natin. Okay? Okay, ito. Yan, beta null, beta 1, beta 2. Okay, so that's okay. Yung mga x, guys, pwedeng ano yan, pwedeng yung mga independent variables natin, pwede siyang cube, naka-squared, naka-square root, naka-log. Pwede yon. When we say linearity of the parameters, only the slopes, the betas, should be linear. Okay. Third assumption is that the variance of the error terms. Okay, so when we modeled our regression, then when you look at the variance, the residuals, they should behave in such a way that there's no trend. Okay, there's no pattern. Dapat random lang siya, no? And we call that a homoscedastic or constant variance na residuals. If there's a pattern, guys, for example, the residuals seem to be moving upwards, okay, or seem to be moving downwards, or there's a fanning effect, F-A-N-N-I-N-G, which means the residuals seem to be increasing or growing over time, parang fan lang, guys, parang pay-pay. Then that's a condition that we call heteroscedastic residuals, heteroscedastic error terms. So hindi acceptable yon, no? Hindi siya acceptable kasi it violates the assumptions of linear regression. So something has to be done with that kapag may heteroscedasticity. Also, multicollinearity. Yung multicollinearity, guys, yung predictors natin, they should be not correlated, no? Gusto natin yung mga explanatory variables natin not collinear. Okay, kasi pag collinear sila, pag perfect collinearity, guys, then we will have a problem kasi we don't know how much of the variance of your dependent variable is being described by one variable vis-a-vis the other variable. Okay, example, guys. Kunyari x1 is, so may x1 tayo, no? May value. Tapos sa x2, is equal to 2 times x1. Okay? So I hope you're getting the point. Si x1, may mga values si x1, tapos si x2 is equal to 2 times x1. So x2 was generated just by multiplying x1 with x2. So pure perfect collinearity yung dalawang yon, no? And if we have that instance where your two regressors are perfectly correlated, we will have a problem with that, no? Ang tawag doon multi-collinearity. Pwedeng hindi perfect collinearity, but still we don't want that the variables to be correlated, no? Kung meron man, weak sana yung correlation nila. Okay, as I mentioned here, guys, pag highly correlated sila, it will be very hard to disentangle which of them best explains any shared variance with the outcome variable. Remember that each of the variable, okay, yung mga independent variables natin, are there to contribute to explaining the variance, the variability of your dependent variable or response variable. So pag perfectly correlated yung dalawang independent variables natin, hindi natin alam kung ano yung contribution ni x1 o ni x2, no? Kasi they're actually the same, no? They're actually the same. They suggest that their two variables, they actually represent the same underlying factor. Okay, so that's what we mean by multi-collinearity. Okay. Also, pag tinitingnan natin yung residuals, guys, they should be independent. They should be independent of each other. So, itong issue na to, guys, this is more for time series to, no? This is more for time series, and this is not an issue with cross-sectional data. Sa cross-sectional data kasi, guys, pwede nating ipagbalik-baliktad yung arrangement ng data natin. Okay? It doesn't matter if we shuffle the arrangement. Walang kinalaman yun kasi wala namang kinalaman yung order ng data natin. Unlike in time series. In time series, you cannot put first 2021 data and then put in the middle 1980 data and then put in the last 1992 data. Hindi pa pwede yun. Kasi may reason kung bakit yung data, the data appears in a chronological order. Okay? So the independence of residuals, it means that the residuals should not be correlated with each other. No? So as I said, it's more a problem with time series kasi kunyari yung 2019 data, pwedeng correlated siya sa 2020 data. Si 2020 data pwedeng correlated kay 2021 data. I mean the residuals, no? The residuals. Okay? All right. So that's a very quick review of what we have discussed so far. Now, again, guys, R, ang ginagamit natin yung mga packages. One good thing with R is that so many have already crafted or they have already done packages. So yung mga functionalities ng packages na yun, magagamit natin, no? And we just have to be familiar with the functions, with the functions that are found in the package. Okay. All right. So we're going to make use of some packages. Okay, yung psych, yung PaceText, olsrr, Stargazer. If you want to know more about these packages, guys, punta kayo sa i-Google nyo, no? I-Google nyo yung what this package does. Okay, and it will be good to read at least ano yung mga functions sila, okay, and familiarize yourself with those functions. Okay, for example, ano ba yung gamit ng site package, no? Okay, if you go here, since na-download na natin siya, tingnan natin dito, no? Okay, napunta tayo sa packages dito. Packages, and then type natin psych. Okay, ito, no? There. Procedures for psychological, psychometric, and personality research. So ginagamit sa research to. Okay, if we click this, wala. Okay, so this is a brief description of what this package is. And then, pwede natin makita yung mga codes dito, no? Okay, yan. Maraming mga codes dyan. Okay, alpha, yan. For example, ginagamit siya in finding for Cronbach's alpha. Cronbach's alpha is a measure used to determine yung reliability ng data natin. Okay, so marami guys, maraming pwede natin magamit, and dun sa tutorial nila, what's good is that wala dito, no, pero may mga tutorial sila dun. So they explain, they give examples on how to use the package. Okay, so that's just an example. Site package, paste text also, etc. Okay, so we won't go there. Okay, make sure that they have been accessed, guys. Okay, and then ano natin guys yung wage data natin. Okay, make sure you have na-load ko na ba? Let me check. Okay, hindi ko pa na-load, so let me load this. Okay, hindi na pala. Okay, so we were working on this last time. Apologize guys for having to have a quick review with this kasi when we go to the stepwise, kung hindi natin review to, hindi natin maiintindihan, no? So let's just once again be reminded what this data is all about: education, experience, tenure, race, gender, civil status, hanggang hourly wage. And we were trying to model hourly wage. We'd like to know whether hourly wage could be explained by these several factors. These factors both are quantitative, numeric, and also we have this categorical. And tapos sabi natin, kailangan natin ma-convert yan. Okay, balik na tayo dito, guys. I'm not going to run everything here, just to, okay. Minsan ang hirap. Ang hirap i-manage ito. Okay. So I'll dispense guys with this. So ito na lang yung structure ng wage natin. Ang structure niya, yan. So these are okay. So meron tayong mga integers, so okay lang yan sa regression. Okay, so hourly wage is numeric. Okay, and then if we're going to use this character, qualitative variables, itong mga white, etc., we have to convert them into factors. Hindi pa pwedeng character yan. Kailangan factors sila kasi ang factors guys ginagamit for classification purposes. Okay, so let's move on guys. Okay, ito descriptive statistics lang. Okay, let's not go into that. Okay. Dito we did this last time guys, yung plotting the data. We can use the sa ggplot, yung qplot, or ito sa base R. Okay. So I won't go there guys. All right. Simple regression, sabi natin simple regression, we just have one variable. Okay. One variable, and then we trying to describe your response variable. So I won't go there guys. So pupunta na tayo dito sa multiple regression na tayo. Okay. So let's go here guys. We have to convert your qualitative variables, your characters, yung race, yung gender, yung civil status, di ba? Ito sila, tatlo. Race, gender, civil status, we have to convert them into factors. Kasi hindi natin sila magagamit sa multiple regression kung ano pa rin sila, characters. No? Okay, so how do we convert, guys? We learned this. Sabi natin, yung wage, okay, ulitin ko to, no? Control Enter. Okay, so there are character variables. So yung wage data, particularly yung race variable natin, as that factor, no? As that factor, ibig sabihin ito guys, same name pa rin. We're not changing the name. So we create an object called wage $raise, and then kino-convert natin into a factor, yung wage $raise. Okay? So let's run this. Itong tatlong to. This 4. Okay, and we can now see that your race, gender, and civil status are now factors. So we can now use them for our regression. Okay, And then we can use in the psych package, meron tayong pairs so that we can see the correlation among the variables. Okay, ito. Kaso yung mga character variables dito, yung race, yung gender, at saka civil status, guys, wala silang kasi mga yan mga factors yan. So there's no sense in including them in our correlation matrix. So what we can do is, okay, again, use the function psych pairs.panels, yung wage data natin, pero isama natin lahat ng rows, pero tanggalin natin si columns 4 to 6. So that's negative C 4 to 6. No? Okay, if you take a look at this, 1, 2, 3, 4 hanggang 1, 2, 3, and then columns 4, 5, 6 are race, gender, and civil status. So when we run this code, guys, from the psych package, the pairs.panels function will give us the correlation matrix of the variables in consideration. Yan. Okay, so ito may mas meaning sa atin. So we can see that among in reference to hourly wage, which is our dependent variable, our response variable, seems like ang pinaka-correlated sa kanya yung education and then si tenure. Okay, and we want variables like that has a high correlation with your dependent variable. Now, as far as your independent variables is concerned, we don't want them to have high correlation. Education and experience, it shows here that there seems to be a negative correlation between them. Weak lang naman, 0.3. Si tenure at saka sa experience, medyo mataas-taas ng 0.5. Tenure at saka education, mababa. So this is good. No? Hindi related si education kay tenure. Si number of dependents, hindi related kay tenure. Hindi rin related si number of dependents kay experience. And very weak yung relationship niya with education. Okay, so that's how we read this, and we would want the variables not to have a strong correlation. Otherwise, we might have problems with multicollinearity. Okay, all right. So let me close this. Okay, so ito ngayon, guys, i-model na natin siya. Balik, very quick review lang. So model 2 ang tawag natin sa kanya. Where sa R, guys, ang regression is we use the linear model, okay, LM, and then the response variable tilde, and then we write the independent variables. So ito, we're using all the independent variables. Shortcut niyan, guys, ganito. Tilde and then dot, okay, and then we have to identify anong data yung ginagamit natin. Okay, so let's quickly run this. Okay. Dito na lang muna. Okay, so naka-parenthesis siya, may partial result na ibibigay sa atin. Okay, ito. So we're given the intercepts, the value of the slopes, but it does not give us whether the model is kung ano yung significance ng mga variables natin. So let's get some summary 2. Okay. So here, guys, it tells us of the significance of the variables dito. No? Okay. So dalawang test dito, di ba? Dalawang test. The first test is the t-test. Kaya nga may t-value tayo dito. So this is the individual test. Individual to because we're testing each of the variables kasama yung intercept. So if you recall, guys, ano yung may null hypothesis to, no? Beta null is equal to bali H null. Let me write that. Ano yung null hypothesis natin dyan? H null is beta null, B null is equal to 0. Okay? Of course, yung alternative hypothesis niya, B1, B0 is not equal to 0. Okay, so ilan yung null hypothesis natin dito? 1, 2, 3, 4, 5, 6, 7, 8. No? 8 yung mga null hypothesis natin. So we're testing each of the variables, no? Whether they're significant or not. Now, bakit naging 8 nga pala? No? Bakit naging 8? Eh, di ba Ilan lang yung variables natin? Okay, ang predictors natin 1, 2, 3, 4, 5, 6, 7. 7 lang. Okay, bakit naging 8? Okay, it became 8 guys because pag may categorical variables tayo, ano ginagawa ni Arjan pag may categorical variables tayo? Okay, kino-convert yan guys into values, no? Either usually 1 and 0. Okay, so kunyari yung race, ilan ba yung race, no? Ilan ba yung race? You have white and non-white, no? So yung race natin, dalawa, white and non-white. So anong gagawin ni R, guys? Do you recall kung anong gagawin niya? Does anybody recall, guys? Anong default na ginagawa ni R? Okay, so let me just quickly show that. Okay. Kunyari ito, no? Kunyari, white, tsaka non-white, no? So, mag-aano lang akong randomize lang ako. Okay. Ganito guys, no? Ito yung ano natin, yung race. No? So, what happens guys is that this will be converted into a dummy variable. Okay? Now question, ilang dummy variable? So, depende dun sa level ng variable natin. Okay, it's always n minus 1. N is a number of types, no? Kung ilan yung klaseng categories natin. Okay? So dito, dalawang categories natin. Di ba? White at saka non-white. So what will happen is that R, or for that matter, any software, will create a dummy variable to replace this. Okay? Ano yung dummy variable na yun? So depende sa software. Kay R, ano yung dummy variable niya? Kung titignan nyo guys ito, yung race natin, white. Ano ibig sabihin nun? What does that mean, guys? Bakit yung white ang nakalagay dito? Anyone? Okay. Ibig sabihin yan, guys. Thank you, Masahiko. All right. Aubrey, thank you. Guys, yung answer niyo, pakishare niyo sa lahat. No? Gagawing 0 and 1, sabi ni Aubrey, that's correct. No? And tama si Masahiko, sabi niya, white comes first ba sa alphabet o si non-white? Yeah, non-white, okay? So, you're correct, Masahiko. Ang sabi ni Masahiko, ganito, no? So, white at saka non-white, sa Excel ko muna pakita. Okay, white and non-white. Okay, alphabetically, which comes first here? Alphabetically, which comes first? C, non-white, di ba? So, ang gagawin dito ni R, guys, lahat ng mga non-white, yun ang gagawin niyang 1. 1, 1, 1, 1. Ito. So, the rest will be 0. Okay? So now, this is our dummy variable. Ito na ngayon yung, and the ones here represent your non-white. Okay? So, isa lang guys yung dummy variable. Isa lang dummy variable. We do not create two dummy variables if there are two levels. Kasi magkakaroon tayo ng dummy variable trap. Okay, hindi pa pwedeng dalawa din yung dummy variables natin. Okay, so kunyari, F, okay, S, J. Example lang to, no? F, S. Okay. Suppose guys, year level yung tinitingnan natin and there are 3 levels, no? 3 levels ng year level. Year level to. Okay. How many types, how many levels do we have? You have sophomore, junior, and frosh. Okay? Hindi na ako nagsama ng senior. Para 3 lang. No? Okay. These are characters, no? So gagawin tong categorical variable, gagawing factor. Ilang dummy variables to? How many dummy variables, guys? Paki-chat. How many dummy variables? Yes, correct. Thank you, Masahiko. 2. Okay, dalawa lang. No? Paano yun? No? Paano? Okay, sa R, titingnan niya, junior, frost muna, tapos junior. So, ang gagawin ni R, and for that matter, any software, meron tayong frost, meron tayong junior. Okay. Okay, so what happens, guys, is that lahat ng frost, 1, 1. So lahat ng non-frost, 0 to. So 0 yan. So this will be the dummy variable for frost. And then sa junior, okay, ito 1, 1, 1, 1, 1. Okay, and the rest will be 0. Okay. So ito si junior ngayon, no? Ito yung frost, ito yung junior. Paano si sophomore? Paano 'yon, guys? Paano siya? Captured ba siya dito, guys? Yes, captured siya ng dalawang dummy variables na to. So lahat ng 0, 0, sophomore yan. Okay, di ba? 0, 0, 0, 0. Yun ang sophomore. So kung yung frost is 0, juniors is 0, then that refers to sophomore. Kaya nga guys, that's the reason why you only have K-1 dummy variables. Okay, I hope that's clear, guys. Clear ba yun? Paki-chat naman please kung clear yung explanation ng dummy variable. So kung 5 guys yung levels ng categorical variables natin, expect that there will be 4 dummy variables for that. And there will be 4 slopes for that, 4 results. And then when we interpret that, guys, pag-i-interpret natin yun, paano yung interpretation yan? Okay, take a look at this. Yung unang output natin, ito. Okay, take note, guys, race white. Okay, race white, ano ibig sabihin nito? Okay, when you interpret this, guys, it refers to what race, guys? To white in relation to your dummy variable. Okay, in relation to your, not dummy variable, benchmark variable. Sino yung benchmark variable natin, guys? Yung hindi nakasulat dito. Diba? Ang hindi nakasulat dito, si non-white. So when you read this, okay, when you read this, assuming this is significant, when we interpret this, on the average, white people receive $0.10996 more, kasi positive siya, compared to their non-white employees, no? Non-white counterparts. Yun ang pag-interpret natin ito. And we did that before. Ito naman, okay, paano to? Gender male. Bakit male na una, guys? Ba't male ang nakalagay dito? Kasi ang benchmark natin si female, no? Si female. So ano ibig sabihin nito? On the average, male employees receive $1.76 more in terms of hourly wage compared to their female counterparts. So laging i-compare, no? Doon sa benchmark. Yung hindi lumabas dito. Kay R, very convenient kasi makikita natin. Makikita natin. Of course, you can do it in such a way that pwede nyo gawin yung si white yung benchmark. Pwede yun. By assigning white to become 1, tapos yung non-white to become 0. Okay, pero ito default ni R. And you'll get the same result, guys. Kunyari kung ang benchmark natin si white instead of non-white, you'll get here a negative value. But the same absolute value, no? The same figure. Okay, ito naman, kung male yung ano natin, benchmark, so magiging gender female to, ang value dito, negative 1.75939. You'll get the same answer. Okay? Clear yun, guys, so far? Clear? Okay, thank you. Thank you so much. Okay. Okay, so inaano ko yung time para makaabot tayo ng ng logistic, no? Okay, so now we know, guys, that when we do regression, multiple regression, there might be some variables that are that are not significant, no? Okay, not significant. So sabi natin, we just don't remove all the variables. We have to do stepwise regression and remove the insignificant variables one at a time. And the basis should be the least t value in terms of absolute value. So dito yung mga insignificant is yan, 0.257 si raise, okay, negative 1.566, okay. Ito significant at ano nga pala ibig sabihin, guys, ng dot dito? Okay, dito nyo tingnan, dot. Okay, ito yun. Significance level is at 0.1. Okay, pag tatlong zero, tatlong asterisk, then it's significant at the 0.001 or 0.1% level of significance. Okay, right. Usually ang hinahanap, guys, yung 0.05 na level of significance. Okay. All right. So what will be our leaving variable, yung aalis? Sabi natin yung pinakamaliit na t-stat. No? So it's raise. Okay? Raise, tatanggalin natin si raise. No? So sa next model natin, okay, so I won't anymore look at the interpretation, guys. No? So I hope you did that. Okay, ano nangyari dito? Okay, so we kept on with the model, guys. Sabi natin, di ba, nagtatanggal-tanggal tayo. Tapos kino-compare natin yung mga models natin using the ANOVA, no, analysis of variance. So sige, hindi ko na, guys, i-compare si mod 1. Mod 1 kasi yung simple regression. Si mod 2 na lang. Okay, so sabi natin ang leaving variable dito si raise, no? So dito tinanggalan natin sa raise sa mod 3. Okay, so let me run mod 3. Okay, mod 3. Okay, hindi ko napapakita, guys. I-compare na lang natin sa ANOVA. Okay. So ito itinetest natin, guys, analysis of variance. Okay, you have to distinguish between the restricted and the unrestricted model. Dito, ang restricted natin is mod 3. No? Bakit siya yung restricted model natin? Kasi siya yung mas konting predictor variables. No? Okay, and the null hypothesis for the ANOVA for these three models is that the restricted model, yung mas konti lang yung mas konti yung predictors is better than the unrestricted. So if we run this, okay, what does this tell us? Yan. The p-value is 0.79, okay? So, ano sabi natin dito? We fail to reject the null hypothesis. Ano ba yung null hypothesis natin? Null hypothesis is that si restricted model is better than your unrestricted. So we cannot reject this, guys. We can't reject this hypothesis. So mas maganda si restricted model natin, si model 3. Yung tinanggalan natin ng raise. Okay? And then move on and continue, guys, hanggang dun sa dulo, di ba? Umabot na tayo dito. Okay? Umabot tayo sa model 5 where ang natira lang, guys, si education, tenure, gender, civil status. Yung 5 lang yun. Yung 4. So out of the 7 predictors, guys, we deleted 3 of them. Okay? We deleted 3 of them. And when we check this model 5, guys, summary, okay. So lahat na ngayon ng predictors natin, they are now all significant. So this means this is already our final model. Final model na natin yan. Okay, so this is our final model. Okay, so how do we interpret this, guys? Education. Again, be sure, guys, to know how to interpret this. So ibig sabihin nito, for every $1 increase, for every 1 year. No? Kasi ang education natin years. For every 1 year increase in education, there's a corresponding 0.53 centavos or 53 centavos or $0.53 increase in hourly wage, no? Kama, ceteris paribus. Ibig sabihin ng ceteris paribus, all things being equal, ibig sabihin, dapat si tenure, si gender, at si civil status, hindi dapat nagbabago. Ano ibig sabihin ng hindi nagbabago? Ang dadagdagan lang natin ng 1 unit, si education. Si tenure, wag natin dadagdagan. Si gender, wag natin, constant din to, no? Pati si civil status, constant din. So we're not changing these other variables. Okay, yung ibig sabihin ng ceteris paribus. Ang i-increase lang natin ng 1 unit sa education. And if we increase education by 1 unit and the other variables remain the same, then the marginal effect of that on our dependent variable hourly wage is 0.53. Okay, guys? Clear so far? Paki-chat nga please kung clear tayo or may questions tayo. Okay. Now guys, ang friendly advice ko sa inyo, no? I-review nyo to, no? Kasi the more you review, the more nagkakaroon tayo ng mastery, no? ng R, ng gamit ng R at saka ng regression. So here nag-ANOVA, tingnan natin. Okay, sorry, hindi ko pa pala na model si model 4, pero when you model this, makikita natin na model 5 is indeed better than model number 4. Okay? So sa autoplot, guys, kasi ang autoplot nasa anong siya? Nasa anong package ba si autoplot? Okay, what package is this located in? Okay, so ggplot2. No? Autoplot is in ggplot2 and I haven't installed ggplot2, so let me just install that. ggplot2. Okay, ggplot2, guys, is a very powerful package for data visualization. Okay, ito yung ginagamit namin sa FINTSAR, no? So we have almost ilang weeks ng ggplot2 talaga yung ginagamit namin. So let me access that. Tapos saka ko na i-run to. Why? Bakit? What happened here? May model 5 na ba ako? Yeah, meron na. Okay. Nag-run ba sa inyo, guys? Anong mali ko dito? Autoplot. Ano naman ggplot2. Naka-install na siya. Okay, nag-error. I'm not sure why this is happening. Okay. Sige. So, how about in your case, guys? Nag-error na ba siya? Nag-error ba siya o nag-run? Yung autoplot nyo? Kindly chat, please. Okay, error. Ano kaya naging dito? Autoplot. You see? Particular plot for an object of a particular class. Okay. Object. Okay, I'm not sure, guys, why. Bakit mag-error siya? Okay, anyway, guys, i-leave ko na muna yon, no? Decipher na lang natin kung bakit siya hindi nag-run. Okay? So, and then, guys, once we have the final model, we say that we have to check the residuals, for heteroscedasticity, etc. No? Okay, so we now go to stepwise regression. Ito, we're going to use this package, olsrr. Okay, so make sure that this is already accessed. And then we'll create a model called model. And then ito yung kanina din, we're regressing hourly wage on all the independent variables. Okay, pareho lang dito yon. So let's run this. So may model na tayo, no? Okay. Okay, so here, guys, here we're creating an object called forwardFit.p, and the code is OLS step forward p. Okay, so this is the function OLS step forward p, and then we would like R to do forward regression, and then the significance level, guys, yung P entering, ibig sabihin, papasok lang siya kung significant siya at 0.05. So itong method 1.1 natin is forward regression using P values. So this is from the olsrr package. Okay. All right, so let's run this. Okay. So ito, guys, forward regression to. No? Okay, stepwise regression to, pero forward. Okay, let's take a look at this. Ano sinasabi nito? So sabi niya, ang unang ipapasok sa education daw. Okay, when you enter education sa model, R squared is 16.48, adjusted R squared is 16.32. Okay, and then we have this, anong variable to, C, it's out, nawala sa isip ko, no? Okay, mamaya na lang, lalabas ulit itong C natin, no? AIC, Akaiki, Information Criterion, and root mean square error. This is a measure of errors. So, syempre, the lower the RMC, the better. Parang AIC din, the lower the AIC, the better. So, susunod na pinasok, tenure, and then gender, and then civil status, tapos nag-stop na siya. So, these are the variables that were part of our final model. Itong ano na to, no? Itong apat na variables na to. Tapos, ang adjusted R squared niya, 36%. Ibig sabihin, 36% of the variability of your hourly wage can be explained by these 4 variables. Okay? And you can see that AIC, based on AIC, mas maganda nga, guys, kung yung 4 na variables as compared to 1 lang. Mas maganda yung 4 na variables compared to 3 variables lang yung gagamitin. Kasi kung si gender lang, kung itong 3 lang, guys, ang AIC natin 2643. Nung pinasok si civil status, naging 2639. Okay? Also the RMSE, root mean square error. Okay? So ano nga pala ang root mean square error? Simple lang, guys, no? Error muna. So that's the difference between the actual value and the predicted value. So that's your residual, no? Comparing the actual value and the residual value. Tapos square. Ano gagawin sa kanya, guys? Square natin. Okay? Square natin ang bawat isa. Okay? Square natin, and we cannot just add everything without squaring them kasi pag in-add nga natin, di ba? 0 yung lalabas nun. So we square the difference, so magiging positive yan, and then we get the average of the deviations, the average of the residuals, and then get the square root. Okay? So yun ang root mean square error. Of course, the lower, guys, the lower the RMSE, the better. So, yung unang model natin, guys, yung forward natin, forward regression, ito yung lumabas. No? 4 yung ano natin, 4 yung predictors natin na lumabas. No? Hindi na siya nagdagdag, guys, ng pang-5 kasi malamang yan, pag naglagay pa siya ng 5, baka tumaas yung, yung AIC natin or tumaas yung RMSE natin. Okay, so i-summarize natin itong object natin kasi yung object natin na create forwardFit.p. No? So we'd like to summarize this forwardFit.p. Ito. Enter. Okay. So ito na yung okay, sorry. Sorry, guys, ha. Sorry kasi pareho lang pala, no? Lumabas na to kasi nag-parenthesis tayo. Okay. Apologies, I thought may mga additional pa na details sa ibibigay. So, okay na yan. Okay? Okay. At ito pala, guys, for us to generate the details, kung gusto natin details, isama natin to details is equal to true. So, same thing. Okay, pero ito ginawa natin panibagong object na forward fit1.p. Again, OLS step forward underscore p. Okay, this is the function na ginagamit from olsrr package. No? Okay. In fact, pwede mong lagay olsrr. Okay, pareho lang yan. Just to signify that this is coming from your olsrr package. So let's run this. Run. Okay. So ito na. No? This is now a more comprehensive output of your forward regression. No? Stepwise, forward stepwise regression. So ito daw yung mga ito daw yung mga variables natin. Yung 7. Okay, so here, kasi sabi natin, ang basis natin will be p-values. Ano ibig sabihin ng p-values? Ibig sabihin yan, ang papasok lang sa model natin, yung may significance na less than 0.05. Okay? Less than 0.05. So step 1, ito. Education yung ipinasok, no? So ito yung mga details na, guys. So this is now a detailed account of what happened, no? Okay, and then step 2 ngayon. Okay, so kung education lang yung gagawin natin, education lang yung parameter na gagamitin natin. So ito yung ito yung regression. Okay? Regression, intercept is not significant, pero education is significant. Okay, ito na guys yung simple regression natin. Okay, if you recall, yung mod 1 natin, yung model 1, which is the simple regression, ito yun. And then next, ano daw nangyari? Step 2, okay? Step 2 is yan. Plus tenure. Okay? Plus tenure siya. Okay. Ano nangyari, guys? Nung pinasok si tenure, okay, so overall goodness of fit, okay pa rin. Guys, remember guys, yung F-stat na to, this is for the overall goodness of fit. And I hope you recall that the null hypothesis here is beta null, beta naught is equal to beta 1 is equal to beta 2. Bakit beta 2? Kasi dalawa na yung independent variables natin. And what's our inference? Since our p-value is practically 0, then we reject the null hypothesis that beta null is equal to beta 1 is equal to beta 2. We have strong reason to believe that at least one of these variables, beta 1 and beta 2, are not equal to 0. It's not equal to 0. And true enough, guys, kung tingnan natin dito, okay, pinasok natin si education at saka si tenure, di ba? Pareho silang significant. Okay, they're both significant. And si intercept naging significant na lang din. Okay, number 3, guys, step 3, pinasok daw si gender. Okay, nung pinasok si gender, ang nangyari, again, guys, yung F-test natin, overall goodness of fit natin, okay yung model natin overall. And then individually, guys, ang nangyari, okay si education, okay si tenure, okay yung categorical variable natin na gender, ang basis natin si female. Okay? Look, significant siya. Lahat siya significant. Okay? So nakita niyo guys dito, ang pinapasok ni olsrr are those variables, okay, that are statistically significant to the 5% level. Okay, last guys, itong step 4, pinasok si civil status. Ano nangyari? Again, dito na naman si ANOVA, no? Pinasok si civil status, and then, okay, civil status, a categorical variable is significant. Yan. Okay, so 4 yung significant na to. Ano ibig sabihin nitong negative 0.685? It means that on the average, single people receive $0.685 less in terms of hourly wage, less than their married counterparts, all things being the same, or ceteris paribus. Negative to. Ibig sabihin si single, mas konti on the average ang natatanggap niya compared to the benchmark, which is the married. Okay, married workers. And then summarize, guys, no more variables added. Wala na kasi pag nagdagdag pa raw, hindi na magiging significant at 0.05. Okay, so this is the final model. Yan, binigay yung R squared, guys, adjusted R squared. Okay, and then yung RMSE, coefficient of variance, and then your mean square error and the mean absolute deviation, mean absolute error. Okay. ANOVA, okay. Parameter estimates, inulit niya. Okay, inulit lang to. Rini-print niya dito sa taas, sa baba dito. And then ito yung summary, no? Selection summary. Okay, so that's what the stepwise forward regression does using the p-enter method, no? May isang method pa, yung AIC method. Okay, so how does this differ? Ito. Okay, ang function OLS step forward. Okay, AIC na dito, no? AIC method. So, i-run natin tong, isama natin details, no? I'll just run this. So, ito yung forward fit1.aic, OLS step forward AIC function. Using the same model and details is equal to true. So, let's run this. Okay. So again, guys, yung forward selection. Okay. And once again, guys. Okay. So paano to? Ano ibig sabihin ito, guys? What does this mean? Okay. Ibig sabihin nito, kung kasama lahat, guys, kung kasama lahat ng variables natin, okay, ang AIC natin 2871. Kung tanggalin natin si race, tapos itong 6 na lang, magiging 2870. So notice, guys, I stand corrected, no? Kung si race lang yung ano natin, yung regressor natin, okay, degree of freedom isa lang. Ibig sabihin isa lang yung ano natin, isa lang yung predictor natin, si race lang, no? Ang AIC natin ng model natin 2871. So among all of these variables, kung isa lang, guys, kung isa lang yung regressor natin, si education ang pinakamaganda. Kasi siya yung pinakamaliit na AIC. So that's what that means. Okay, I hope it's clear, no? So bakit si education ang pipiliin natin as the first variable? Kasi if we're going to compare these variables, if we're going to use them individually, no? Kunyari si race lang, si number of dependent lang, si gender lang, etc. You'll have this akaiki, no? And you'll also have this adjusted R squared. Ilan ang kaya niyang i-explain dun sa variation ni hourly wage. Si race nga, 0 eh. Okay, at least si education 16%, no? So yung unang entering variable natin based on AIC will be education. Okay? So yun, plus education, yun daw ang unang ano natin, no? Ang AIC natin is 277.423, yun ang pinakamaliit na akaiki, no? Okay, ang model natin, hourly wage education. Okay? Second step, guys, kung magpapasok pa tayo ng iba pa, okay, tingnan nyo. Kung ipapasok natin si tenure o si gender, sino yung pinakamaliit na AIC na magre-result? Okay, ang pinakamaliit natin, guys, pag ipasok natin si tenure, 2685, no? Alright, 2685. So, pinakamaliit na AIC, no? Okay, I hope that's clear, guys. So, kaya nga plus tenure dito. Plus tenure. Okay, so kung kasama na si tenure, dalawa na yung variables natin, education at saka si tenure, okay, ang AIC natin bumaba. Kanina 277, ngayon 2685. So, okay ito. No? Okay, third. Okay. Again, guys, ano mangyayari? So, sabi ni forward stepwise using AIC, pag ipasok natin si gender, in fact, bababa yung natin, ano? Kasi ngayon, 2685. Pag pinasok natin si gender, bababa yung AIC natin. Huwag natin ipasok si race kasi tataas, diba? Magiging 2687. Okay, okay din si experience, 2683, bababa as compared to 2685. Pero guys, ang pinakamaganda, gender. So enter gender. Enter gender, yan na siya, tatlo na siya. AIC natin 2643 na. And so on and so forth. No? Ito magiging, ipapasok daw si civil status, magiging 2639. Okay? So pinasok si civil status. Okay? Pinasok siya. 2639. Okay? And then dito guys, dito. Okay? Dito, Pag pinasok daw sa experience, magiging 2638. So bababa yung AIC. Okay? Bababa yung AIC. Okay? Wag lang si number of dependents kasi tataas siya. Alright? So dito guys, based on AIC, pinasok si experience. Pinasok si experience. Kaya nga dito sa model na to guys, okay? Ang final AIC natin 2638.6. Kung ipasok pa natin si number of dependents, tataas na si AIC, magiging 0.80 na. No? Okay? So here we have the final model, 5. 5 yung yung ano natin, 5 yung predictors as compared to yung kanina yung P method, yung P-enter method na 0.05, okay? 4 lang. Ito 5. So ito medyo iba guys, ano? Kung AIC method yung gagawin natin, ipapasok niya si experience. Pero kung p-value yung gagamitin natin, hanggang civil status lang. Let's take a look at the final model. Okay, so sabi, ito yung variables to be entered. Education, tenure, gender, civil status, experience. Okay? Tapos tingnan natin guys, yung model natin ito. Okay, take a look now guys. Ito, yun. So lahat are significant. In fact, si civil status nga, barely, no? 0.051. Barely significant. Lumampas ang konting ng 0.05. Pero sa experience, look, 0.12. So based on a significance level of 0.05, okay, when we use the P method, okay, rejected to. Okay, rejected dapat yung experience. Pero kasi sinabi natin, no? Sinabi natin, gamitin mo yung AIC, tingnan natin kung ano mangyayari. Okay? All right. So which of the two, guys? Ang standard ang ginagamit natin si p-value, no? Okay? Kasi ito significant na at ano lang at 20% lang, ano? Okay? So we can see here that there's a difference between the AIC method and the P method. Pero mas acceptable guys yung p-value. Unless guys we're not very strict about the statistical significance of the independent variable, which is rare. Rare naman yung ganung case na hindi natin kino-consider yung significance. No? Okay? So ito yung selection summary kasi nga binase niya dun sa AIC, no? Pag pinasok daw si education lang 277. So once you enter these variables, okay, tingnan niyo sa experience, bumaba yung AIC. Okay? However nga, hindi siya statistically significant at not even at 0.10. No? Okay, so this is a sabihin natin discrepancy, but to be safe guys, gagamitin natin yung p-value. Okay? Any questions so far guys? Clear ba yon? Paki-chat naman please kung clear. I hope guys na pasensya na kung medyo nag-monologue ako dito, no? Okay, I just want to make sure that tapos natin to kasi pending natin to last time. Okay, next method guys, backward regression naman. Kanina forward Forward na stepwise regression. Ito backward regression. So, ang difference nila sa forward regression, you start from scratch, isa-isa natin ipapasok. Okay? So either based on p-value or based on AIC as we have shown a while ago. So isa-isa natin papasok, kunyari yung p-value, titignan natin. If pinasok natin itong variable na to, okay, significant ba siya? Okay? Etc., etc., etc. No? Okay, so ito naman guys, backward. So sa backward, we start with everything, no? We start with everything and then we run. Okay, so ito, backward fit that one P. Ito, OLS step backward P. So let's just take a look at this P. P remaining 0.05. Ibig sabihin, ang magre-remain lang dapat yung mga variables that whose p-values are 0.05 or less. Okay, so i-run natin to. Isama natin details. Let's run this so that we see what's happening here. Okay, so ang advantage ito guys, hindi na tayo mag-iisa-isa. Di ba manual natin to dati? Isa-isa natin to. With this guys, with the olsrr package, ito na. Binigay na sa atin yung final na model, no? Based on either stepwise na forward or stepwise na backward. Okay, so let's look at this guys. Okay, backward elimination method. So una candidate terms itong lahat, no? Lahat. So, anong sabi? We are eliminating based on the p-value. So X daw si race. Yan ang unang tatanggalin. So step 1 guys, variable removed. Itin natin, tinanggal si race. So ano nangyari guys nung tinanggal si race? Anong nangyari guys? Dali binigay po sa atin dito. Okay, hindi, no? So first, ang tinanggal si race. Okay, when we remove the race, guys, ito nangyari, no? R squared natin, adjusted R squared. Okay, then ito yung model natin. Okay, so si race tinanggal, no? So wala na siya dito. Okay, pero may mga variables pa, guys, na not significant. Si number of dependent, not significant. Si civil status, not significant. Si experience, not significant at 0.05. Okay, and again, alam natin na ang unang tatanggalin dito is the least, no? Least in absolute value, which is, in this case, it's this one, number of dependents. 1.33 kasi yung t-stat niya. Pinakamaliit na absolute na t-value. Alright, so we expect that the next step will be remove number of dependents. So yun nga, guys, tinan nyo. X daw, tanggalin si number of dependents. So this is now our step 2. Okay? So ang model natin, ito na yung mga computations ng R squared, etc. Okay? Tapos sa ilalim dito, okay, overall goodness of fit, okay naman guys. After removing number of dependents, okay pa rin yung model natin. And then, let's take a look at the individual stats. Okay. So meron pa rin mga insignificant. No? Si experience, 0.12, insignificant to. Si civil status, 0.051, insignificant din. Okay, sandali, baka may nag-chat. Okay, thank you. All right. So, which will be the leading variable, guys? Alam natin na sa experience. No? Kasi yung t-value niya, absolute value nito is the least as compared to this other insignificant variable. So, x natin si experience. So, R did it already for us. X si experience. So, step 3 na tayo. Nung tinanggal natin si experience, ano nangyari? Ano nangyari, guys? Okay, overall goodness of fit, okay pa rin, no? Okay pa rin yung model natin. And then here, yun na. No? Yun na. You notice, guys, kanina 0.051 yung yung civil status natin, yung significance niya. Okay? Pero nung tinanggal, guys, yung number of dependents, naging significant na siya. Kasi most probably, baka nag-aagawan yung dalawang yon. Si number of dependents at saka si civil status. Okay, nag-aagawan sila in explaining yung dependent variable natin. So when tinanggal yung isa, okay, hindi na nag-aagawan, no? sa explanatory factor yung dalawang variables na yun. Okay, so that's it, guys, no? That's it. So sinamarize siya, variables removed, race, number of dependents, experience. Final model output, again, inulit na to. Ito yung final model output natin, and then ito na yung significance sa mga variables natin. And you know how to explain this, guys, I'm sure. Okay, and then elimination natin, ito, tingnan nyo Okay, remove race. Okay, remove race, yung adjusted R squared natin, 3631. Okay, tapos remove si number of dependents, adjusted R squared natin is 3621. You notice, guys, na yung adjusted R squared, lumiliit yan pag binabawasan natin independent variables. The more we add independent variables, the more the adjusted R squared will be. Natural, guys. Kasi pag dagdag tayo ng dagdag ng variables, lumalakas yung explanatory factor ng model natin. Kaso nga lang, we will be penalized, no? Nape-penalize tayo, guys, sa AIC. Mape-penalize tayo kung dagdag tayo ng dagdag ng independent variables. So dito, tinanggal natin sa pangatlo yung experience. So it's only naging 36% na lang yung natin, yung explanatory power, yung adjusted R squared natin. Okay? Okay, so ito yung elimination summary natin sa backward. Okay? Now you can also do backward regression using AIC. Kasi kanina yung backward regression natin, we use P value, di ba? Okay, so i-run ulit natin to. Details is equal to true. Let's see what happens. Okay. All right. So tingnan na lang natin, guys, yung final model natin. Okay, tingnan natin yung final model natin, guys. Okay, look at this one, guys. Okay, so ano siya? Consistent siya with the forward model, no? Sinama pa rin yung 5 kasama yung experience ba yung dulo natin? Okay? Sinama yung experience, no? Okay? So itong AIC, whether you do forward or backward, pareho din yung kakalabasan. Okay? All right. So we can plot, guys. We can plot the model. For example, di ba may model tayo na backward fit.aic? Pag i-plot natin yun, oops, hindi ko pa rin yung backward fit AIC. Saan ba siya? Dito. Sorry about that. Ito. Backward fit. Ito. And then, AIC pala. Backward fit. Asan na si AIC? Okay, here. Backward fit.aic. I-run ko siya. Okay, so ito final model kaagad, no? Full model. Ang tinanggal na lang niya si race at saka si number of dependents. Okay? Kung lahat daw ng variables kasama, AIC is 2640. Pag tinanggal lang natin si race, 2638. Pag tinanggal natin si number of dependents, 3638. Okay, so binase lang niya sa AIC. Okay, so if I plot this, dito na ako guys sa plot sa dulo. Okay, so that we finish this. Okay, this one. Okay, naran ko na si backward fit.aic. Okay, plot natin. Okay, tingnan nyo guys, ha? Okay, so this is the plot of the AIC and the variables. Kung full model guys, lahat ng variables kasama, so ito yung AIC. Now when we remove race, bumaba yung AIC, no? Sabi nga natin guys, di ba, the lower the AIC, the better. Okay, and then tinanggal pa si number of dependents, bumaba pa lalo. Okay, pag nagtanggal pa tayo ng isa guys, tataas ng AIC. Kaya based on the AIC method, dalawa lang yung tatanggalin. Okay? So dito guys, may intermediate tapos yata ito, no? Yeah, we're done with this one. Okay. Yung details is equal to true. Nagawa na natin yan. Okay, how about this one? Okay. Now ito naman guys, both, no? Both fit.p. So pareho niyang gagawin. Okay, so let's ito na lang guys, both fit natin, i-run natin to. Okay. So we're using the model guys, yung buong model natin. P enter is equal to 0.05. Okay. P remaining is equal to 0.05. So dapat isasama natin yan. Kasi yung P enter, this is for forward. P remaining, that's for backward. No? Okay, sige, print natin. So this is both, no? Both methods. Okay. Medyo matagal. Mukhang hindi tayo aabot sa okay. We're selecting based on p-value. Step 1, i-add si education. Okay. Tapos step 2 daw. Ipasok si tenure. Step 3, ipasok si gender. Step 4, ipasok si civil status. And then wala na. Wala na. Ang both guys, ang pwede mangyari niyan, may idadagdag tapos may ibabawas. No? Okay? So, yun ang pwede doon. Pag both fit, you can add and then, kasi dun sa forward kanina, pag in-add na natin guys, hindi na pwedeng ilabas. No? itong both fit, pag dinagdag natin, pwede pang ibawas. No? Okay? Alright. Pero para sa atin guys, okay na yung, yung backward. No? Usually, ang ginagamit talaga backward. Okay. And then, okay, both fit then using AIC. Okay, I'll leave that. Okay, tapos i-plot lang natin si, hindi ko kasi na ano to, no? Hindi ko na run si both fit, i-run ko na lang. Okay, and then plot natin. Okay, so using, this is stepwise AIC, both direction. Okay, so here guys, ano to? So pwedeng, ano combination to ng forward at saka backward, no? So nagsimula siya, education. Okay, and then, ano nangyari dito? Pinasok si tenure, bumababa yung AIC habang while you're increasing the number of the variables, and then pinasok niya sa experience kasi bumaba yung AIC. So this is quite similar to to the forward kanina. No? Walang masyadong pagkakaiba. Okay. All right. Ito naman guys, ito yung all possible subsets. This is a very comprehensive result. Okay, medyo mahaba itong result na to. Okay, just to explain guys, anong ginagawa dito sa, let me just, okay, take a look at this guys. All possible subsets to, no? Number one, education lang yung predictor. Education lang. Kung education lang guys, ito yung R squared, ito yung adjusted R squared. Okay, then pinasok si tenure, no? Tenure. R squared naging, hindi, sorry. Yung 1 n dito guys, tigi-isa lang, no? Yun ang count ng variables, n. So kung isa lang guys, kung isa lang yung predictor natin, si education ang pinakamaganda kasi siya yung pinakamagandang adjusted R squared. No? Okay. And then kapag 2 guys, kapag 2, so notice guys, yung mga 2 dito, dalawa na. So kino-combine na niya yung dalawang variables. So sino yung pinakamaganda? So based on adjusted R squared, ang pinakamaganda yung combination ng education at saka tenure. 0.299. The rest are just mababa. So etc. guys, etc. So ito, kunyari, number 4. No? So lahat ng possible combinations ng 4 variables. Pagsasama-sama niya yan, tapos i-compute niya yung adjusted R squared. So sa 4 guys, sa 4, here, sa 4, kung 4 variables lang guys, ito yung pinakamaganda. No? So education, tenure, gender, civil status. Okay, the adjusted R squared is 36%. Yung iba mas maliit, etc. Etc. Okay, so okay, I think that's about it, guys. Okay. Okay. Plot to, see. Plot natin, yung mod compare natin. Okay. Okay, anong ibig sabihin nito, guys? Okay, plinat lang niya yung mod compare natin. Let me access this. Okay. Nasaan na ba yung ano natin? Okay, anyway. CP Marlowe to, no? CP Marlowe. Okay, so CP Marlowe guys is a statistical measure. So hindi ko na-discuss sa inyo. Hanapin niyo na lang guys, Marlowe's CP pala, MARLOW. Kung ano yung mini-measure nito. The lower the better din to, no? Okay, so this one guys, ang pinapakita dito, ito, no? Okay, kung one variable lang, itong triangle na to ang best, si number 1. Sino yung si number 1 guys? Yung nasa mod compare natin. Asan ba yung mod compare natin, guys? Ito. Ito, no? Sino yung number 1 natin dyan, guys? Number 1 is ito. Yan, number 1. Yung index, no? Education lang. So, itong plot natin na to, guys, it tells us which is the best model in terms of R squared or adjusted to R squared kung 2 variables yung index number 8 daw. Okay, kung 3 variables, 29. Kung 4 variables, yung number niyan, guys, nakalink dun sa dun sa mod compare natin kanina, no? Okay, so this also tells us kung R squared ang gagamitin, kung adjusted R squared, kung AIC, okay, sino pinakamaganda? Kunyari ito, no? Kung 4 variables, according to R squared, model 64. Adjusted R squared, model 64. CP, model 64. AIC, model 64 din. So medyo consistent sila, no? Kung 4 variables, according to Schwartz Bayesian Information Criterion, model 64. Schwartz Bayesian Criterion 64 din. So consistent sila in almost all. So comparison lang yan, guys, kung isang variable, 2 variables, 3 variables, 4, etc. Kung yun ang gagamitin, ano yung pinakamagandang model. Okay? So, questions so far, guys? Questions so far? Wala na tayong time. Okay, anyway, pakita ko na lang. Okay, are there any questions, guys? So, I'm happy that we were able to complete, no? Although mabilis yung pag-discuss ko. Okay, anyway, I'll be posting the video. So, paki-review na lang. Okay? So, we have 2-3 minutes lang natitira. Ano ba yung comments nyo? Okay, thank you so much, guys. Okay, thank you so much. Okay, so paki-ano na lang, guys, paki-try nyo na lang, ha. Tapos I'm thinking of, kasi next week tayo, no, Friday, baka mag-post pa ako ng isang video, okay, before Friday, to run yung logistic regression. So ito. Logistic regression ito. Here. Okay, ang gagamitin dyan, guys, na data is yung binary CSV, yung sinare ko rin sa natin. Okay, logistic regression, guys, it's like regression, kaso ang mga independent variable, ang dependent variable natin are categorical variables. Is a categorical variable. So ilan lang sandali natin to, guys, no? Kung saan yung sinave yung yung data, okay, ito, i-enter ko yung read.csv file.choose. Okay, so it will open mag-open ng, okay, ang tagal. Dapat mag-open siya ng nag-run pa. I still have 2 more minutes, guys. Tagal, ah. Taking so long. Na-access yun na, guys. Kailangan file.choose, may lalabas na dialog box asking you to choose. Meron na ba akong my data? So yung binary CSV, wala pa akong binary. Taking so long. Ito na lang. Import ko na lang para mas mabilis. Import. Okay, pwedeng read R. Text. Guys, may I have 2 minutes, guys? Extension. Okay lang ba? Permission, please.
Yes, sir.
Okay, thank you. Thank you. I-load ko lang yung tagal. Ano nangyari dito sa ko? Paki-load, guys, yung natin, yung data natin, yung binary.csv. And then we'll call it my data. Okay, thank you, guys. Thank you. Hindi lang to. It's taking so long. No, ayoko i-terminate. Ang tagal, no? Hindi na mabasa. Nabasa niyo na ba, guys? Nabasa niyo na? Paki-chat nga, please, if you were able to read yung binary.csv. Okay. Sige. Anyway, since I can't open it, all right. Thank you, Masahiko. Thank you, guys. So, kindly look at this codes, guys, kasi magkakaroon tayo dito, guys, ng yung ginagamit sa machine learning na ini-split yung data. No? We could have done that dun sa linear regression natin, pero hindi pa natin ginagawa. So dito, magpa-partition ng data tayo. And we use partitioning the data kasi ang ginagawa natin dyan, dito 80% and 20%. No? What happens is that we split the data so that 80% of the data, we will use it to model logistic regression. And then yung remaining 20%, gagamitin natin para matest yung model natin. Okay, so it's important for us to have new data that the model has not yet seen. Okay, para matest natin yung data yung model natin sa new data. Okay, so it looks like hindi siya okay, so let me end there. Okay, so I'll stop recording.